My name is Madeline Cooper. I'm the Education Program Coordinator at KCD. So if you've emailed to ask any questions, I'm who you've been communicating with, but I am also here with Jay and Megan, who are our work on our farm team at King Conservation District, who will be giving the presentation and answering questions today. And then we also have Lene here. And I think I'm just gonna go ahead and turn it over to Jay and Megan.
Sounds good. Thanks, Madeline. Thanks for joining us today. Jay and I have worked together for many years. I'm a farm planner with the district. I've been with the district for about 8.5 years. And I can let Jay say a little bit about himself too. But a lot of the work that we do is working in our rural areas, primarily educating people around sustainable agriculture and for the benefits of soil health and water quality. And so we ended up coming up with this presentation because we had a lot of interest in questions about soil and soil health. And so hopefully everyone learned something from today and benefits. And we'll also share our contact information at the end. And feel free if you have additional questions or more in-depth questions about anything we talked about today, like feel free to email us. We're happy to answer more questions. Did you want to say anything, Jay, before we moved on?
Yeah, great. Thank you. Again, I'm Jay Miro, resource planner, and happy to be giving this presentation. It's our first time, and this presentation really came out of the soil test interpretation talk that we've been giving for many years. And we got a lot of questions about soil health and things that were a little bit different than just looking at nutrient tests. So this is our first run. So give us some feedback, tell us what you think. And yeah, like I said, we're happy to present this information. And Megan, why don't you take us away?
Awesome. Yeah, so we'll go jump to the next slide. We'll just talk about what we're going to cover today. So this is our outline. We're going to talk a little bit about the conservation district, in case you've never heard of us before. Some soil basics, just because we need to have just a kind of basic understanding about what soil is. We're not going to go do a deep dive on it, but just have general understanding about soil. And then Jay's going to jump into, well, I'm going to talk a little bit about what soil health is, and then Jay's going to jump into soil health practices that everybody can do to improve their own soil at their home. And then we're going to talk a little bit about our soil testing program and soil contaminants. So with that, so the King Conservation District, in case you've never worked with us, is a non-regulatory special purpose district funded through rates and charges. So every parcel in King County pays a small rate into our agency, which then we use mostly to put back out into the community in grants and all kinds of cost share projects. And lastly, every county in the state and in the country, for the most part, has a conservation district. So if you don't live in King County, I would go online and look for your local conservation district. We're all a little different, but we offer similar services, trying to tailor to what the community in your area needs. So you can check that out. And then Madeline's going to send out a whole lot more detailed information about KCD, but I also encourage you to go on our website. So conservation districts in general are very small. Some counties only have a staff of 3 or 4, agency folks working there. And so you can see so what I was saying is that we're spread through word of mouth a lot of the time. So I wanted to let you know in this presentation about all of our services so that you know that they're out there for you. We have soil nutrient testing, which we're going to talk more about later in this presentation. A very popular native plant sale. Keep your eye out for other educational programs. I'm going to give a new pollinator talk in March that I'm very excited about. We do a lot of restoration work on our shorelines and forestry restoration work. Community ag. Miranda Smith is here today, and she manages our community ag program. And then the farm world that Jay and I help with farm conservation management, agricultural drainage, equipment rental program for farmers, and then a bunch of different grant programs where we give out lots of money to support the community and our local food system.
Yeah, conservation districts were formed as a response to the Dust Bowl. And we won't go in a lot of detail about the why and how districts were formed, but Franklin Roosevelt said it best. The nation that destroys its soil destroys itself. The work of the conservation districts are based on soil, not only soil erosion, soil health. And of course, we've added water, air, plants, animal, wildlife, and human issues to our concerns, but it really is based within the soil.
All right. So jumping in a little bit into soil basics. So if I could leave you with a few things from this presentation, one would be that in the soil science world, one does not call soil dirt. Dirt is a forbidden word in the soil science world because soil is a dynamic natural body composed of mineral and organic solids, gases, liquids, and living organisms, which can serve as a medium for plant growth. So we want to leave you with a healthy reverence for soil and all of the amazing things that it does for us. So with that said, we have this great graphic here that shows a whole host and world of things that soil does for humanity and our environment and our world. It can help, I won't go through all of these, but it can help with soil contamination. Like you spray Roundup on your yard, and the reason that Roundup doesn't live there forever is because the microbiome in the soil breaks those compounds down. Climate regulation. We're going to talk about carbon sequestration in this presentation. Nutrient cycling, very important and related to carbon sequestration. Habitat for organisms. One of my favorite things to talk about is soil biota, which we're going to talk about more. Flood regulation, very timely after the historical flooding we saw in December. Soil in poor health does a much worse job of mitigating for big flood impacts, and it can actually exacerbate flooding issues. Obviously, the foundation for all our homes and structures that we build. Construction materials, our historical cultural heritage in different areas, and then it grows our food and fiber and fuel. And so we're going to talk a little bit more about some of these things coming up. So just really quickly, how is soil formed? So it starts with parent material, and then over time, that material becomes weathered by climate and topography and time and breaks down. And then there's inputs from plants and animals. And there's a lot of different statistics about how long it takes to form 1 inch of soil. When I was trying to look it up, it ranged from 100 years to 1,000 years to 1,000,000 years to create 1 inch of soil. And so, yeah, it's something to think a lot about, to take care of our soil so that we don't lose it because it takes so long to rebuild. So soil is the mineral and organic matter on the surface of the earth that serves as a medium for plant growth. And so if you took a big core sample down into the bedrock, this is what you would see. And so what we're kind of focused on is improving the soil in the layers that we can control, the A and O layer, O meaning organic layer. And then you can see that as it gets deeper and deeper down, it's because more and more parent rock and just material and less life and just more base rock. And so because it's the mineral and organic matter on the surface of the earth, we want to be careful about how we treat that top layer. And so grading and fill and development can really have a negative impact on that subsoil layer. A lot of times when construction happens, we scrape away that subsoil layer, and it can really change the quality of the soil health in those places. And in fact, in Seattle, so there's an online service that we can send you where you can look up what your soil type is where you live, but it doesn't work for the city in Seattle because there's been development in the city for so long that there's no way of knowing exactly what soil type is still there in different areas. So soil texture, soil scientists have lumped soil texture into 3 basic sizes: sand, silt, and clay. And so sand being the largest particle size, you can think about a beach. It's not good at holding onto water, but has a lot of large pore space for holding air. So when the tide comes in at the ocean and then it recedes, how quickly that sand dries up, not good at holding water. And then the inverse of that is clay, which are teeny tiny microscopic particles that are very closely spaced. And there has not as much space for air because of the small pore space, but it can hold a lot of nutrients and a lot of water. And then the kind of Goldilocks in between version of that is silt, which is the medium-sized particles. And I like this graphic over here because you can just see sand in itself is very small, but in relation to clay, it seems so much larger than a clay particle, which is invisible almost. And so there's this great triangle, the famous triangle for soil texture, where it has the sand, the silt, and the clay, and how different combinations of sand and silt and clay will create different soil textures. And if you were able to just pick your optimal soil texture, if you could control that, you'd want to go for a nice loam because it's a mixture of all three. So it's got the balance of being able to hold airspace and water and nutrients and be really productive. And in fact, in our area, the farmland that has a silt loam is actually considered farmland of statewide importance. And that's like a statewide designation because it's so rich and valuable. And two other examples of soil that are opposite of that in our area. Alderwood gravelly sandy loam soil is our most common soil type, which is comes from glacial till. I'm sure if you've ever dug into it, you know, because you hit rocks very quickly. We call it droughty because it's not great at holding onto water, but it's really well draining. And the inverse of that is Buckley soil, which has a lot of clay because what happened was when Mount Rainier erupted about 6,000 years ago, there was a huge mudslide. You might have heard of the Osceola mud flow. And so there was a big flow and it put all this clay mud in some of our areas, but it's really productive. It's great for growing hay, great for crops, but really hard because it gets water saturated. And so it's harder to have livestock on or homes or structures. And so the next is soil composition. So we talked about soil texture. So that's that mineral component in the ground. And so you're going to have different mixtures of sand, silt, and loam in that mineral component. But then there's the space around the minerals. And so we talked about the water and the air, the two components. And every soil, depending on the texture, can hold different amounts of ratios of air and water. And then there's also organic matter, which is that last 5%. And that's kind of the life, what gives soil life. So soil structure, this is actually one of the things we can control in terms of keeping healthy soil. So well-structured soil has large pores. I kind of think about it like if you're gardening and you put your hands in the soil and pick up a big handful and it's that beautiful crumbly texture, you've got well-structured soil. Like those are actually called soil aggregates, those crumbles of the soil. But poorly structured soil, so soil that maybe is left uncovered all winter, and then is driven over, and then maybe walked over and has no plant cover or no plant living roots in the ground. The pores, everything gets kind of compressed and dense, and then there's smaller pores. It gets compacted, the water can't drain, and so it has compounding effects on poor soil quality. If you walk on it in the wintertime, it's going to be hard. It's hard to grow things. It's real crumbly. It's kind of the difference. And so it's kind of a classic farm example of good soil structure versus poor soil structure and plant productivity. And so we can say maybe on the left side, there's a farmer trying to grow a corn crop, and he's done a great job. He uses no-till techniques for seeding. He tries to keep tractors off in the wintertime. That corn creates long roots in the soil, which in and of itself helps create great soil structure, and those living roots keep the soil in place and prevent soil erosion. And all those things have compounding good benefits to them. And then the inverse of that would be maybe a conventional farmer who plants corn, plows the field every year, doesn't plant a cover crop so that the water is just running over the soil all winter, taking erosion, creating erosion with that. Maybe when he tills in the summer, that soil then gets cooked by the sun, and then he's driving his tractor across. And so that soil slowly gets compressed over the years, more and more and more, to the point where there's something called a tillage pan. So under the plow layer of the tractor, it's actually like a solid brick because of so much use over the years. And I encounter a lot of farmers in my work that have ponding issues they struggle with. And then I actually did this recently where I went out to a farm and I took tests with a penetrometer, which reads soil compaction. And the whole farm was compacted 12 inches down. And they had no idea, but had been conventionally farmed for about 40 years. And so it's something very common. So soil organic matter, one of my favorite things to talk about, because this was really what gives it's the difference between dirt and soil. It's what gives soil life. And so the way organic matter gets into the soil is first there's fresh residue. Classic example is in the fall, the leaves fall down to the ground. Or maybe when you mow your grass, if you leave the fresh residue, the grass clippings in your yard, you got fresh residue being put down to the soil. And so then the next thing that happens is the microbes and the soil biota get to work and they start decomposing that organic matter. So they're breaking it down. And then once they've broken it down, it's stabilized organic matter called humus, which is a rich, nutrient-dense layer that's full of benefits for the soil and for growing things. And then all the creatures in there doing all that work are the living organisms, which are also organic matter. So this is just a cool picture of a soil food web. I read a cool statistic that 1/4 of life on Earth is in the ground under our feet. And we're learning more and more that we should really recognize the benefits and how important the soil fauna are. From earthworms, which are really great at creating soil aggregates and soil structure, and worm castings are full of nutrients, both macro and micronutrients for your soil. Moles, which can be the bane of some existence, but they actually do a great job creating soil porosity and eating pest insects that would otherwise be damaging. And then the fungi and the bacteria, and they all have an important role in our soil health. So this is one of my favorite videos. This is a process called bioturbation, and Jay's going to let it play while I talk to you guys and explain what you're looking at. So this is an experiment where they took one section of leaves and put it with soil, and the only thing in there is a little bit of fungi. So you can see that fungi that popped up, but otherwise there's no life in there. And on the inverse, they have fall leaves full of the normal soil life that you'd find. And you can watch the difference and how you're seeing them integrate all that organic matter into the soil profile. But while they're doing that, the earthworms are creating pores and those aggregates, and they're breaking it down and creating more soil. So I just think that's so cool. And then we also want to start talking more about how important soil is in absorbing carbon and its impact on climate change. And for some reason, the video's not there, Jay. Oh, there you go. Okay, so it's a hard, complicated topic to explain, but I found this great video Organic Valley made that explains it in a fun way and in a short 1-minute snippet. So I'm going to let Jay play that, and then we'll move on from there.
Carbon atoms are the building blocks of all life on Earth, and the exact same amount of carbon has been on the planet since the day of the dinosaur. So why does it get such a bad rap today for accelerating climate change? It's a matter of balance, and today our carbon cycle is not functioning the way nature intended. Here's how the carbon cycle should work. Animals eat plants, which are made from carbon, and they return it to the atmosphere as carbon dioxide through respiration and elimination. Plants capture this atmospheric carbon dioxide and sunlight to provide themselves with food through a process called photosynthesis. Excess carbon is then stored in the plant biomass or the soil. Storing or sinking carbon is called carbon sequestration. Scientists estimate that the pasture land in the U.S. alone sequesters as much carbon as 88 million vehicles emit in just 1 year on the road. However, when the rate of carbon being emitted is greater than the amount of carbon being sequestered, the cycle becomes overwhelmed. Organic Valley believes ethically.
So I should also preface, we do not specifically endorse Organic Valley specifically as a source of milk, but I forgot to mention in the beginning of this presentation, I'm also the dairy planner, so I work with all the dairies in our county. What is soil health? So there's one more slide, and then we're going to toss it over to Jay to talk more about soil health practices. So I think we've kind of already talked about all of these things, but just to reiterate it one more time, so you go away very excited to think about all of the functions that soil does for us. You can kind of skip through, Jay. Like, healthy soil retains and cycles nutrients, crucial to us being able to grow anything on this planet. Supports plant growth, sequesters carbon, infiltration of water, super important. Suppresses pests and diseases and detoxifies chemicals. Yeah, more supporting our food and fiber and fuel economy, provides habitat to our wonderful and amazing biofauna. And then, yeah, just soil biology drives plant growth and just creates a healthy system. So the things Jay is going to talk about coming up next are kind of ways to get maximum benefits out of your soil so that you get the maximum all these amazing functions.
Well, thanks for the quick primer on soil. And so now we're going to talk about the practices themselves and how to build healthy soil. But before we get in it, I always like to just kind of bring it back to home, and why it matters to you is because healthy soils and increasing soil health, following these soil health practices, right, it will make it your garden, your vegetable plot, your farm more productive. And we went through a lot of the benefits, but if we really want to bring it personal, we can grow better vegetables, have healthier gardens by following soil health practices. So what are the soil health practices? There's basically 6 different areas that we're going to talk about tonight. Minimizing soil disturbance, maximizing soil cover, increasing biodiversity, integrating livestock when and if possible, having continual living roots, and last but not least, talking about the context. The principles of soil health and regenerative agriculture, they're very similar, and they can work on both large farms and backyard gardens. So what you would do on a large farm or even a large plot of land might look a little bit different, but the practices themselves are the same. So you might hear that in the news or out and about, regenerative agriculture. It's very similar to soil health. So now let's go on to disturbance. So what is disturbance? And really, this is any activity where you physically disrupt the soil structure, the composition, right? This could be plowing, disking, flipping, digging, doing construction, right? So anytime we disturb the soil, that is a disturbance. And what does that do? Well, right, it destroys the pores, it destroys the ecosystems that nature has been creating. When we destroy the pores and the structure of the soil, there's that potential compaction, like we saw on the soil structure. We saw the plow layer, the plow pan. This can increase ponding. It can reduce drainage, right? Every time we mix or we flip or till a soil, we're actually killing some soil biology, but we're also kind of shifting it to a more simplified, less complex system, right? We're reducing the amount of soil fungi. And really, the soil fungi are a major part of nutrient cycling, of holding water in the soil, right? We increase the ratio of bacteria to fungi. And when we have more bacteria than fungi in the soil, it's less healthy. It's less able to cycle nutrients and all the benefits that we just talked about. And of course, a field like this or a garden like this is just ripe for weed seeds to either land, or if they're in the soil, it's just perfect for them to establish. So that soil disturbance does a lot of damage to our soil. And how do we minimize soil disturbance, right? We leave residue or the leftover parts of a crop on the soil. Maybe we do cover crops and let it slowly integrate it in the soil. We avoid heavy machinery. So whether that's driving a tractor, whether that's you using, a small lawnmower on wet soils, walking in our gardens a lot, anything to reduce the compaction. Leaving roots in place over winter, so not removing all of the plants after the season's over in the fall. And then, of course, considering when and how often we mix or plow or till, and really doing as little as possible. Right? Does this mean I can no longer mix or turn over the soil with a broad fork or a shovel? I mean, you can, but our hope is that you try to reduce the frequency and the intensity and really consider when you're doing it, why, how often. Because again, we're trying to retain that soil structure. We want to keep the structure for the soil, for the fauna in the soil. And so we want to reduce the disturbance as much as possible. Can you rake or hoe a bed? Yeah, this does very minimal disturbance and does minimal harm to the soil health. So yeah, if you have to rake, and this is a great way to manage weeds. So we're not saying don't disturb the top surface. It's really that mixing. Can you dig holes to plant starts in? Sure. Just don't dig really big holes. Just dig what you need. Right? We're not saying eliminating it completely. It's just doing less is going to help the soil structure. What if you do need to till? What if you have a really big weed infestation and really the only way to recover is through tillage or using heavy machinery? Just because I tilled last year or the year before, right? Why do we do the same thing over and over again? So really what we want you to do is consider that need. And if you do need to do it, if you do need to till, well then do some of the other soil health practices, the things we're going to talk about to mitigate for that. The next one is soil cover, right? We really want to maximize the soil cover, and that's keeping living or dead organic material on the soil surface. And as you can see, right, that's going to regulate the soil temperature, protect from compaction. And as most of us know, bare soils are subject to erosion, moisture loss. They get really cold in the winter and really hot in the summer, lose organic matter and nutrient runoff. So bare soils are sort of our enemy on a lot of cases. How do we increase soil cover? Cover crops. Winter cover crops, summer cover crops, interseeding. So this is the practice where we're planting plants either in the rows or having multiple tiers of crops, some things that grow tall, some things that grow low, like the Three Sisters planting that we've heard about, where it's peas, corn, and squash. So they're taking into account the verticalness, but they're also covering more of the soil, right? Leave that plant material in the garden. You don't have to have a completely bare garden at the end of the season. Leave some of that residue or the material. But surface mulches work as well, right? Whether that's wood chips or cardboard, leaves in the fall, or even burlap, just something to protect the soil surface from all those negative impacts of bare soil. You could plant perennials or having perennials mixed with our annual crops, and then doing overwintered crops, whether there's the cover crops, but there's also planting things that will thrive in the winter. So things like kale, Swiss chard. Lots of different cover crops, and cover crops provide a lot of benefits, certainly to soil health, but of course, here's a nice list of things that cover crops can do for us: reduce erosion, organic matter, helps with nutrient cycling. We'll talk more about nitrogen fixing, biodiversity. So really, cover crops are plants that we specifically plant usually at the end of the growing season. And we may not harvest them, so they're not necessarily a harvestable crop, but they can be. How do you use cover crops? Right? Pick the crop that meets your needs. On the next slide, we'll talk about how to do that in a little more detail. But basically, different crops have different benefits. Seed at the recommended rates, and for winter cover crops, you want to get the seed in the ground by October 15th. And although that's not a magic number, when we seed too much beyond the 15th of October, it just gets a lot colder and we don't see very good germination. And usually we're seeding pretty heavy. And each area, it would just depend on the square footage or acreage that you're managing. So not only is it important to get the seeds in the ground before fall or during the fall, but you also want to terminate them before they go to seed in the spring. Some of our annual cover crops are really prolific seeders. So managing that is really important. On a backyard garden scale, generally what we do is we would cut the cover crop and then cover it with cardboard or soil or plastic. Usually you want to do this somewhere between 5 and 10 weeks before you want to plant. That way that material has a chance to decompose. And however it would work for you, I guess burlap is another one, and some wood chip mulch. That way it just has a chance to break down. Right, we're picking our cover crops are really going to depend on our goals. And the Western Cover Crop Council just came out with this cover crop decision tool. And you can follow the link using the QR code on your screen. And this will take you directly to their website. But a good cover crop is for beginners is annual rye and hairy vetch. It establishes really quickly, and the annual rye will provide some biomass, and then the vetch provides some nitrogen fixing. But again, different sites, different goals, legumes, right? These are great nitrogen fixers. So things like crimson clover and field pea and hairy vetch, right? They fix nitrogen. On their roots, there's these little nodules that they have, and it hosts a bacteria that will take nitrogen out of the atmosphere and bring it into the soil. And in fact, we can estimate that a very well-established legume cover crop will provide, it's 20 pounds per acre of nitrogen, or a half a pound per 1,000 square feet. In our other talks, we've talked about how to interpret our soil test. And so if you did that, when you take your soil test through the KCD soil testing program, now you can estimate, right, in 1,000 square feet garden, a healthy cover crop will provide about a half a pound. That's about a quarter of what a vegetable plant will need per year. And of course, that depends on the crop. Now, grasses make great cover crops as well. They're not going to provide the nutrients, the nitrogen that the legumes do, but what they do provide is a lot of biomass and organic matter. And so here's a shot of annual ryegrass, and you can see from the picture how densely it establishes. So that's going to outcompete weeds. It's going to have a big root system. But if you let that go to seed, you're going to have annual ryegrass for a long time. So termination is going to be pretty important. And then this is also a lot of biomass. Getting this cut down early enough in the spring so it decomposes is going to be pretty important. Or pulling it out if this is your vegetable garden. But it may make a good mulch. So you might be able to plant in between and use that as a surface mulch. So again, cover crops provide a lot of benefits. There's a few other ones out there. Forage radish. This can help with soil compaction. Buckwheat. This is a good summer cover crop. Good for pollinators. You might need to be watered. Fava beans. This is another legume and actually could be a crop. At KCD, we do have a cost share program that can support cover crops, and our community ag program, we have a cover crop giveaway program. So, take a look at our website and see if those are something that you could utilize. So the next practice is increase biodiversity. This one is pretty interesting. I'm not going to go into a lot of detail, but essentially what we want to do is fuel the wildlife within the soil. And if we think of a jungle ecosystem or our temperate rainforest that we're in, right? Animals need shelter, they need food, they need water, they need nest sites if they're birds or other places, to raise their young. And just like the animals in the forest are soil wildlife, they need those same things. So we want to do things that promote the wildlife within our soil, right? The tillage is going to ruin the habitat. And so other things can negatively impact the biodiversity. And that soil biota, right? It is the foundation of nutrient cycling. That soil biota, like we saw in Megan's video, and you could see the earthworms moving all around. So they're creating pores, and the pores are places for air to go in. They're places for water to flow through. And it increased biodiversity. This is going to help with pest and disease control because they're not going to be able to establish. There's an ecosystem where different pests and diseases are going to be controlled by the biota. And of course, drought and extreme temperatures, a soil that has more water or more organic matter, more oxygen, is not going to heat up as fast or dry out as quickly. How do we do this? Well, crop rotation is a good one. Excuse me. We don't plant the same crop in the same section of the garden year after year. That crop rotation brings, diversity of roots, which we'll talk about in a second, and it prevents pests from establishing. Planting cover crops, right? Providing that fuel, providing that habitat for those microbial creatures in the soil. Intercropping, right? Maximizing the number of plants in an area. And of course, chemicals can really decrease the biodiversity in the soil. So whether this is chemical fertilizers or using, pesticides, herbicides, and of course, fungicides, right? These can either kill or reduce the ability of the biodiversity in the soil to thrive. Adding surface compost or mulch, right? Like we saw in the video where those creatures were pulling that material down. And so the larger earthworms are going to pull larger pieces down, and the smaller, creatures are going to eat the castings and what's left. So adding surface compost is a good way to fuel biodiversity. And of course, the crop rotation and the diverse cover crops are going to create this root diversity where there's different species of plants with their roots supporting different types of soil life. And we'll talk about that in the next section, right? We just want to fuel a food chain the best we can. We'll talk a little bit about continual living roots. And of course, this time of year, right, the plants aren't growing very quickly, if at all. However, plant roots have a thriving ecosystem. They call this the rhizosphere. And as you can see from the picture in the middle, there's kind of that blue area surrounding the plant roots. And plants sort of try to create an environment to encourage the microbial life that helps them thrive. So a lot of our plants will create root exudates. So this is a type of like food that the plant will send out of its roots to attract fungi, to attract bacteria and other, soil biota to kind of encourage it to live near the roots. And in exchange, they'll provide that nutrients, like they'll cycle the nutrients, they'll shift, ammonia and nitrogen from a unusable form to a plant usable form. And so there's this whole ecosystem around the plant roots. And it's quite fascinating to think about how our plants are actually communicating in these non-verbal ways to encourage an environment where they can thrive. In addition, all these roots create channels in the soil, which not only allow, things like earthworms and other larger creatures like nematodes to travel, but it also allows for water and air to move through. The roots of the plants grow and they die, and so that growing and dying, creates kind of the structure within the soil. And of course, that's where the carbon is. The plant's roots, as they shed throughout the growing season, leave that carbon in the soil. So of course, carbon sequestration is pretty important. The practices, of course, these are all looking pretty similar to the other soil health practices, but by doing crop rotation, we're doing cover crops, that interplanting, perennial plants, leaving plants alive over winter, and then just leaving dead roots in the ground. All kind of creates that basis for that soil biology. Now, integrating livestock, not always practical in a small urban backyard. However, chickens and on larger farms, other livestock, they can not only provide some nutrient deposits and organic matter, but they can kind of scratch the surface, do some pest control. They kind of eat some of the residues of the plants. And you want to think about density. Of course, having too many animals on too small of an area can cause problems. And of course, they might eat plants that you want to keep alive. So there's challenges here, but definitely, right, a lot of our plants have grown and evolved with animals in their kind of how they evolved. And so where appropriate, livestock, chickens in particular, can be an important part to kind of keep that soil health on a positive trend. Right, we've heard the term permaculture, and it's a system that we have a regenerative loop, interconnected system of plants, animals, buildings, people that kind of support a healthy, growing system. And a lot of the principles of good soil health, regenerative agriculture, are following a lot of the principles that people have been talking about in the permaculture world for a long time. This is a particular book that our board member put together about chicken gardens, but right, chickens, like we said, can be a part of it, but certainly it's kind of integrating everything together. And that's kind of our hope of what we've talked about tonight. And the last section is context, right? Soil health is about promoting a healthy soil ecosystem through compounding good practices, right? We want one good soil health practice to build upon another. So we try to reduce our tillage, which is going to set the stage for a good ecosystem. We're adding compost. We might be reducing chemicals when we can, right? We want one practice to build upon another. We add compost and we plant cover crops, right? We're building it in a positive fashion. And that's really what soil health is about, is having that one practice builds upon another. But different situations are going to look different. So your farm, your backyard garden is going to be different from mine. My time, my energy is different than yours. So what works for me may look different from what you do, right? Maybe someone's growing more vegetables, and the only way they can manage it is through using heavy machinery. And I mean, that's okay. Maybe we can help them reduce the amount of tillage, but we're going to mitigate that tillage by recommending doing cover crops, doing a surface mulch, and reducing chemicals. So different soil health practices will be different on different properties. And just a few take-home thoughts, right? Soil health is a journey and not really a destination. And we have to be adaptive with these practices, right? I want you to start thinking about not only what's good for the plant, but what's good for the soil. And so it's just adding one more piece to consider when we're doing things. And really, it's about doing the practices that work for you. Because at the end of the day, like if you're not getting what you want out of your garden, just because you stopped doing tillage, right? Obviously, it's not going to work if you're covered in weeds, if the garden is covered in weeds, and the only way you can control them is through tillage. So we're not saying you have to do all of these, but it's choosing to do enough of them that you can have soil health go in a positive fashion. And with that, we're going to talk. I'll shift back to Megan and we'll talk about our nutrient testing program. Megan?
I did the classic forget to unmute when I started talking. Thanks, Jay. Yeah, I see a lot of really good questions in the chat too, so I'm excited to answer some of your questions after this. We just wanted to let everyone know that we have a very popular soil nutrient testing program. So every parcel in King County has, unless you're within those few cities that don't support our rates and charges, you have 5 free soil tests per parcel or property. And so you can test your garden, your lawn. We've had people test their forest, soil, pasture, field, cropland. And so there's a QR code. You can scan that, and that will take you to our web page that has all the information you need on how to take a soil test and how to submit one. But essentially what you can do is you fill out the submission form. If you're trying to test something specific, you want to include that, like I'm trying to figure out how to get better production in my blueberries. And then the lab will give you specific recommendations back on how to manage for whatever specific thing you're trying to grow. That's all on our website. You need to send in 3 pounds of soil, but all the details are there. You can also, if you don't live in one of the jurisdictions, if you live in one of the jurisdictions that doesn't have the 5 free soil tests, you can still use our program. It's just $40 per test. And then, yep, so take advantage of that. And yeah, it can help you start understanding your soil health. Well, the last thing we're going to talk about quickly for a few minutes is the Tacoma smelter plume and how it's impacted our soil and put contaminants into our soil. So what you're looking at right there in that picture is Tacoma, and that is a 570-foot, 1-foot tall smelter plume, smokestack. So that was owned by the American Smelting and Refining Company, also known as ASARCO, and they operated several copper smelters around the country for about 100 years. So they operated this from 1890 to 1986, closed in 1986. And this plume, as they were operating the smelter, went and spread out around about 1,000 square mile area, and it was sprinkling lead and arsenic onto the ground in that area and contaminating the soil. Mostly it contaminated the top 6 inches of soil. And we go to the next slide, and you can see a map of kind of the zone there. And so you see that dark purple zone, that really got the heaviest hit of lead and arsenic from the smelter, which has since been deconstructed. That smokestack no longer exists. But if you're worried, if you think you live in one of these areas and you're concerned, there's a dirt alert map from the Department of Ecology. You can also scan the QR code here, and it will take you to that information. You can use our free soil testing program and add lead and arsenic testing to your test, which is additional $38 per metal. And then you can get those levels back. You can also attend a soil shop to get free in-person testing this summer, which is a new program that we just started that is being managed by Miranda Smith, who's joined us today and can answer any questions about that. But we're trying to do more education and remind people about the history of the soil in our area. So with that, I'm excited to turn it over to questions, but also feel free to email Jay or myself if you have any additional questions or just want to talk about anything related to soil.
Yeah, thank you, Jay and Megan. Lene is going to ask the questions. We are getting a lot of questions in the chat, so I just want to preface this with Jay and Megan will try to get through as many as we can. But if there's ones that are unanswered at 7:30, we will just write answers out in the resource email, and we're also happy to always follow up via email after this talk. So yeah, I will turn it over to Lene to start getting these questions out.
Yeah, lots of good questions. We'll start with, how do you start a garden without tilling? That's from Buell.
So there are ways to kind of smother the grass. That could be, if you have a lawnmower, cut the grass really short. It just helps reduce the sponginess, or a weed whacker, cut it really short, and then put either cardboard down. Sometimes burlap would work, or plastic, and then you could cover, if you're using cardboard, cover that with wood chips. And so that you would have to let sit for several months. If you could have done it in the fall and let it sit over winter, that will smother the grass. Plastic does okay too. Put down plastic in the fall and you smother it over winter, or you could do that in the summer, and then you could solarize the grass where it just heats up and it kind of kills it. So yeah, smother the grass somehow if you're doing it in a lawn area.
On a similar note, somebody said that their soil is incredibly clay-like, and they're wondering how to improve soil structure and health without tilling.
Yeah, so clay soils can be a problem. in that they don't drain as well, and then they dry out too quickly. So depending on the situation, right, there's kind of a couple approaches you could do. I mean, there's always the build a raised bed. And so then you can kind of manufacture your soil. If you wanted to, you could add some organic material to the soil. Depending on the size, you might be able to mix other soils in, right? Or do kind of a mounded bed. So those are some approaches: adding organic matter, building raised beds, adding a sandy loam soil to the clay soil to try to loosen it up.
I would also say too, if it's really clay and you're having issues with like it ponding and staying really wet, cereal rye is a really great cover crop that you can plant that can handle really wet soil. And I was kind of wondering if you have maybe some compaction issues compounding the fact that your soil has a lot of clay, because most of our clay soils are highly productive. And so that cereal rye would grow and has long roots, and it could help break up any compaction that might be present and help get you better productivity.
All right, thanks guys. And then, do you have any recommendations for native cover crops?
You know, I didn't mention that in my slide. I had a note, but I forgot to mention it. So this is a great question. A lot of our native plants don't actually make good cover crops, right? Because they're very adapted to where we go, to where we're living. And so they're not going to perform quite as well as a introduced cover crop. They just don't have, like, there's not great characteristics of our native plants that are going to provide the benefits that we want. Either they're slow to establish, or there's not anything that really is going to be fixing nitrogen. So I often don't recommend using native plants as cover crops. Now, attend Megan's pollinator talk here in March, because what you could do if you wanted to have more natives and attract more pollinators is you can make the boundaries of your garden area with the native plants to attract the pollinators, but then use, right, our introduced species. Like, we use them as give them a job and then eliminate them, but then plant natives on the boundaries to attract beneficial insects.
Can
I
I
would
add
also-
something? Oh, sorry, Megan.
Oh, I was going to say, I would also add, it's a little bit of an aside, but another reason I love native ground covers is you can plant them in your ornamental landscaping, and you can plant them around the bottom. And instead of putting mulch down every year, you can let beech strawberry or woodland strawberry take over, or knick or stonecrop. And those all support our native pollinators, which if you attend my webinar in March, we'll talk about more, but that would be a great place to put native ground cover.
Yeah, I was just gonna add too, I love when people like have this instinct of like using native plants as cover crops, but the things that we want from our native plants, which is like creating this whole diverse ecosystem to support our native food webs and wildlife and insects, that's not really gonna happen as much when then you're coming in the spring and mowing them down and not letting them like grow up. So I love the ideas about incorporating native plants into your gardens, like in other ways where you'll really get those like long-term benefits of native plants.
Plant more natives, just not in your veggie garden.
All right. right. Someone, I think you guys mentioned using hairy vetch as a cover crop before. Someone said that they've tried that and they are still trying to get rid of it years later. So they're wondering when and how do you harvest it to get the benefit of the vetch, but not overwhelmed by it everywhere for years.
Yeah, I have hairy vetch all over my front garden. It's quite annoying. And bird's foot trefoil. There's bird's foot trefoil everywhere. I have no idea where it came from. Maybe it came from a plant I bought. That's a good, right? That's just a good reminder, not only the hairy vetch, but a lot of our cover crops, if we don't terminate them at the right time, can become a weed. Not all of them, but just a few of them. So it's really understanding the plant and when it seeds and what type of establishment that it does. So most plants will seed in the spring. So if you're able to start that termination process, April, depends on where you are and where your frost date is and when you want to get plants into the ground, but it's somewhere in the April time frame. And like I said in the presentation, cover it and to smother it. Cut it down and then cover it with, right, burlap, wood chips. I'm reading somewhere that someone mentioned that cardboard has PFASs, forever chemicals. So, oops, I did not know that. So, let's hope not all cardboard has those chemicals, but right, you want to smother it, and that takes a few weeks, right? It's a multiple week process. Plastic, if you want to use or have plastic, you can cover it with the plastic, but right, then you possibly will have bits of plastic over time. So
You could also chop it in if that's a manageable thing to do, the size or scale of your garden. You can chop it into the soil. Put green
yeah,
mulch
you
back
want to
in.
kill the root. Kill
Mhm.
the root.
All right, and then we know that dog and cat poop can't be composted in the area, not even in municipal composting facilities. But what about rabbit waste? Can that be composted in a home garden?
It's herbivore manure. So yeah, you can compost rabbit manure. Just make sure it composts, right? Follow, general composting guidelines. So it breaks down into a more plant usable form. And we haven't had a composting seminar in a while, but basically you're managing three things to compost. You want to have oxygen, so it's an aerobic process. You want to keep water out in the winter and moisture in the summer, so cover it. And then, make sure you have a good carbon to nitrogen ratio. The more carbon woody products you have in the compost, the slower it takes. And so if you manage those three things, air, water, and carbon to nitrogen ratio, whether that's manure, whether that's, plant residues, you'll give enough time, you'll make a compost.
Cool. And then we have a landscaper in the audience who finds that clients often want leaves removed if they don't break down fast enough, and that creates a positive feedback of worse soil health over time. Do you have any suggestions on what to do in these scenarios?
Yeah, I love talking about leaf compost. I know a lot of people have probably heard the saying, leave the leaves. But if you're in the landscaping company, leaves also smother the grass and don't maybe create the most aesthetically looking environment for your yard. They are full of nutrients. I used to share a TED talk where someone talks about composting leaves down, and the key is chopping them up. So if you're able to chop them up, and they turn into a great source of nutrients. So maybe if you're able to chip the leaves, you could continue to use them or spread them out as a nutrient source without smothering the grass completely. At my house, I have woods next to me, so we just blow the leaves into the woods and let them decompose and do their thing there. But that's a great thing to remind folks about. And also the leaves on the ground create habitat. They're important for native pollinators that mostly nest in the ground. They create cover for them. And so there's a lot of benefits to keeping the leaves, with the challenge and the caveat that if you're trying to have a nice green lawn, it's not the most ideal.
And maybe there's a
Mhm.
balance approach
Mhm.
where you could talk to your client and be like, okay, how about would you consider this area, the front yard or the show yard? This is a leave remove area, and then this area is a leaf stay. That could be an option. Or, right, again, it's about not doing necessarily every soil health practice, but it's thinking about the soil health practices that work in context to what, in this case, the landowner wants. So instead of you relying on the leaves to be part of that organic matter, deposits, maybe we're going to use, a small application of compost instead, and then that can kind of fuel the biodiversity in, if we're talking about a lawn situation, um, but in a garden or a ornamental garden, it could be the same thing. A very small amount of compost applied or wood chip mulch each year to kind of continuously adding and fueling the biodiversity. So, right, if it's just about choosing what makes sense for the situation.
Also, just so folks are aware too about leaves, a lot of our native insects overwinter in those leaves and have larvae in there that they bed down in. So it's also habitat. So there's a lot of value. And if you're able to make a leaf pile and let it just decay over on its own, that's a great way to also maintain wildlife habitat.
Awesome. A couple folks were wondering about interplanting. They've had issues with some plants kind of suffocating others. So how do you choose what to interplant?
I think I saw that question about interplanting. And my first thought was what I do with my garden is I don't start seeding my cover crops until a little later in the season. So I let my veggies kind of get a good start and a lot of biomass, and then I plant around them so that they don't get outcompeted. I love crimson clover, so I start planting crimson clover around July so that it flowers and the bees can take advantage of it. But I make sure that my other plants have been, at least a month or so to get established before I start planting my cover crops so it doesn't compete with them. And clover is great because it doesn't get super tall or a ton of biomass. And it's pumping nitrogen into the soil for your veggies to take advantage of.
For planters and planting tubs, do you have any recommendations for keeping good soil health without replacing the soils every year?
Well, I mean, certainly adding just a little organic matter every year, not a lot, just a little. So you're, increasing fueling the soil biology. You could also be thinking, right, let's not kind of doing the heavy tillage or the digging to kind of keep the soil structure, right? You could still do some of the other things where we're doing crop rotation and we're doing, cover crops. So, those are all things that whether it's a raised bed or a, large planting tub or in the ground in the crop field, like those are all things that everyone could do to increase soil health.
And if it's outside and if the tub doesn't have a bottom, nitrogen is something we're always trying to put back into our gardens because we lose it during the winter with our rains. And a general potting mix is really rich, or garden mix from soil that you buy at your local garden store is really full of nutrients. So I think it would take a long time to really deplete the soil. And so, just thinking about doing some amending, like Jay said, a little bit every year will go a long way in productivity, especially nitrogen.
I mean, you could jumpstart it by, like, if you have a worm bin, although that, oftentimes worm bins are on the ground where, of course, the worms are coming in, but also other soil biota is coming in. So, as you empty that worm bin, certainly that could go into a raised bed and kind of jumpstart some of the soil biota.
And then jumping over to wood chips, is there a species of wood that is particularly good or bad to use as chips, or can you just use whatever's available?
I was reading in there that someone had some comments about different species. I have not looked into this, so I'm not sure. I do know, sometimes this particular commenter there, you can get poisonous things. Sometimes you can get invasive weeds, right? A tree covered in ivy that's all chipped up. Uh, I have gotten free material and then I have random weeds. I think I got leafy spurge once, and it's still the bane of part of my garden. So, yeah, knowing what the materials are, cedar, right? If someone's chopping up a cedar tree, that may not be ideal because of a lot of the the tannins. It doesn't break down very quickly. A lot of the preservatives, natural preservatives in cedar may not be good for growing in the garden.
And I think related to that, someone asked if pine needles are good for the soil in the garden.
I think they are. Of course, pine needles are kind of fuel for acidic soils a little bit. So it's just a matter of not overdoing it.
Yeah, they contribute. All our soil is naturally acidic because it's historic forest soils, and mature forest systems have really acidic soil profiles. And I think pine needles are one of the contributors of that. So, but you can add lime and other amendments that raise the pH of your soil up too, which is another thing to think about. And that'll go a long way to kind of getting more productivity out of your garden, because the ideal pH range for a veggie garden is around like 6.5. But it's not uncommon to see a soil of around 5.5 in our area.
And where I live, I have to like chase the chip guy down the street when I see them because there's not a lot, but like it's not as, there's not as many chippings going on where I live than when lived in Seattle. I could always find chips. So I have to be less picky because I can only get what I can get. And it seems like whenever I'm out, I'm like, it takes me a long time before I can convince someone to dump the chips here. So I tend to not be as picky, but I'm not necessarily saying that's the best management practice either. So yeah, take that into account for sure. Yeah, there's chip drop. I think there's a website. It's like Chip Drop where you can get on free chip dumps. Yeah, there Rodney likes that. So
Do you have any tips on attracting earthworms if you don't want to outsource them, I suppose?
You would earthworms are there. They're there, and if you don't have earthworms, my first thought was like, let's figure out what's going on with the soil. Do we have really bad compaction issues? Is there no organic matter in the soil? Has there been development recently there? So I think what you need to do is kind of troubleshoot and figure out maybe taking a KCD soil test will help get you some information on if there's no nutrients in your soil or any organic matter. But it'd be very uncommon to not have earthworms. So those are kind of my thoughts, to kind of do some troubleshooting and figuring out what's going on in your soil profile. Maybe planting some, if it isn't vegetated, that could be a huge indicator if the soil heats up and bakes. So maybe getting something just planted, something that can grow there and start putting living roots in the soil. and breaking up soil compaction could be a good way to start that, but it's a good question.
How do you guys feel about Austrian pea as a cover crop? Do you think it's a good one?
It is good. I love it. Doesn't create a ton of biomass. It's pretty manageable. It's pretty. Does good in my
And
garden.
and what I'd recommend is going to the Western Cover Crop Council and selecting that plant, the Australian pea, and then you can learn all about the conditions that it likes to grow in and the benefits that it provides. So I think there's about 60 or 70 different like recommended cover crops on that Western Cover Crop Council. And they're specific to, well, all of the West, but you can narrow it down by our kind of ecotone, right? Western Washington, like not too cold, not too hot. And I think parts of Oregon were in the same area. And so they looked at cover crops that kind of work in our environment and then like gave conditions and the characteristics of each of the plants. So use that tool. It's a pretty good tool.
But it does grow well in our climate.
Does harvesting potatoes disrupt the soil? Should people stick to grow bags or the Ruth Stout method?
I mean, the harvesting of potatoes is extremely damaging to the soil structure, and there's really no way around it. So do not grow potatoes. That's of course one option. And I think the grow bags may be a good, option for some. I didn't have very good success when I tried that, so maybe I did it wrong, but I didn't have very good success. But okay, we know we're going to do heavy disturbance by digging out the potatoes. And if we want to grow potatoes in the ground, there's no other option but when we dig them out, we're going to mess up the soil structure. So that's a great case of, right, we're going to do soil destruction, soil structure, soil disturbance. So now do a cover crop, right? Do a little compost, right? Maximizing soil biology, right? We start to do the other soil health principles to try to mitigate for that.
And I would
Maybe
say
we
that's like, oh, sorry, Jay, I didn't mean to interrupt you.
No, I was just going to say rotate, do crop rotation.
Yeah, I was going to say that's why crop rotation is so important, because then the soil can rest after that year growing potatoes and it can recover.
Right, so all of our soil health principles are not thrown out the door just because we're going to grow potatoes, right? We do some of the other things to mitigate.
Someone's been composting for years and actually took a soil test that said they had too much organic matter. Is there a problem with too much organic matter?
Too much, it can be too much of a good thing. It's true. Yeah. The problem with if there's so much organic matter in the soil, the microbes are now working really hard to break all that down. And so they're actually using up the nutrients that you'd want in your soil for growing your veggie garden or your lawn by trying to break that all down. So what you can do is you can put beneficial bacteria, you can inoculate your soil, giving them more bacteria, and that will help kind of quicker break down the organic matter. That is true. So if you get really high organic matter and you feel like you're not getting the productivity you should be out of your garden or your lawn or wherever it is, try to inoculate it with some bacteria that are beneficial, and that'll kind of help speed that process up of breaking it down, and you might see more productivity. But if you're putting organic matter in like a general compost in your garden year after year after year, you might be overloading it with organic matter, which is something our free soil test would tell you if you took advantage of that.
And really what at that point, if you're seeing a production issue, uh, right, supplementing with nitrogen is probably what's going to be the solution. And really the soil test is going to tell, but the number one question I get when people call me asking about their soil test results is I have high organic matter and low nitrogen, and my productivity is low. So it's not a given, but it's definitely, like Megan described, high OM, organic matter, kind of causes the nitrogen to nosedive, which then causes the plants not to thrive. Not always, but
The bacteria, essentially, they need food to fuel them to break that organic matter down, and nitrogen is one of the things they need in large volumes to be productive. So I'd be like trying to run a marathon and you've only eaten celery for the week. It's like you need some protein so you can run that marathon. You need to give the bacteria some supercharged fuel.
All right, tons and tons of good questions just keep coming in. We've got time for probably 2 or 3 more. We're just going in approximate order of when they were asked. So someone left some unharvested root crops in the ground and later in the season found white worms, typical root crop pest, in the decomposing roots. And it made them question whether leaving those was a good idea. They're also wondering, wouldn't tillage radish planted as a cover crop attract the same root pests?
I mean, that's where crop rotation will fix that. So, right, we would move and have that root vegetable in a different location in the garden. And so, therefore, we wouldn't have any pests from that 1 year's growth going on to the next year's growth.
I have not had that happen with my forage radish, but in these situations, I always defer to the master gardeners with like specific pest issues, and they can give you recommendations on how to avoid that too. And they're at farmers markets, and you can even on their website, the master gardeners website, you can submit questions to them, and they can help try to troubleshoot like specific pest issues too. But our area is very prone for pests, crop pests.
And so maybe
Mhm.
instead of a tillage radish, right, which is very like right to address your soil compaction, maybe we do something else with a really aggressive root system. I know alfalfa doesn't grow great here, but there's varieties of alfalfa that have a really deep taproot that might be able to work as an alternative if, right, you have a root vegetable pest problem. So, right, use alternatives.
All right. Someone's got a very sandy soil and parts of it won't grow anything unless they add tons of water. They've also tried adding compost. Do you have any tips on what they should try growing?
Compost is so basically with a really sandy soil, you might have the way to kind of increase the water holding capacity and productivity is to add organic matter into it. And so compost is a great way to do that. So if you're able to integrate compost into that top soil profile, that should definitely help. Compost, we used to talk more about it in our previous former presentation, but it's kind of a great all-around source of organic matter and our macronutrients and our micronutrients, which are kind of like the vitamins for the soil. And so that's a great way to, what you're doing is already a great way to kind of increase the production capacity of your soil and if it's sandy. But it might also just like I live on Everett soil where I live, and that's the most well-draining soil type in our area. It's very droughty. And so you just might have to integrate like, irrigation for sure.
What are some viable alternatives to plastic for warming up your soil if you don't have access to hay?
Warming up the soil.
I mean, a good
ahead, Jim.
established cover crop will provide that thermal, let's call it insulation, right? If you have a nice cover crop on the soil coming into the spring, that's going to cause the soil to be warmer. And do you have something else to add, Megan?
No, I wasn't sure if that question was in relation to weed control or this garden establishment. Mhm.
You know, a row cover, of course,
Mm.
that's plastic. So I don't,
Would
because you want the
burlap
sunlight to,
be helpful?
a what?
Burlap? It's not going to
Burlap,
trap as much heat as plastic, but maybe better than nothing.
a cold frame,
Or
right? That's
mulching.
good.
Mhm.
Yeah, mulching.
Mhm. Mhm.
Sounds
With
like
mulching, you just really want to watch your nitrogen levels then also in terms of having a lot of organic matter in the soil. Mm.
sounds like plastic is almost a necessity for keeping things warm. For a veggie garden, does top dressing with manure sound like a good idea each spring?
All about how much, right? Manure is just like any other fertilizer. It has a certain amount of nitrogen, phosphorus, and potassium. So, I mean, adding just like the person who said I add compost every year and now I have a really high organic matter percent. You do the same thing with manures, and you could over time, and particularly phosphorus is going to get really high. So you can overdo compost just like you can overdo uh, compost. So you just want to keep it to a small amount. And I'm talking small, like, a half inch. You don't need a lot. I think the problem is when we add inches and inches. Um, yeah, right amount, right rate.
Huh. All right. I think that is all we have time for questions today. There were a few that we didn't get to, but we'll type up some answers to those and share them with you in an email. And yeah, we just really appreciate our presenters and Miranda and Lene for helping out today, and for all of you for coming and sharing your enthusiasm for healthy soil and asking such great questions. So thank you so much and have a great rest of your night.